Hello, everyone. Welcome to our session on governing AI models, tools, and agents with Azure API Management. In this session today, Mike, Srikanth, and I from the API Management team will walk you guys through the latest developments on API Management to govern models, tools, and agents, and also walk you through some demos to showcase how our product is helping developers and enterprises manage various kinds of AI endpoints and governance. In this session today, we are going to walk you through how we can help enterprises deploy AI in production and apply their governance framework. Then we'll walk into in details on the latest developments in terms of model governance, tool governance, enterprise registry, and agent governance. And obviously, across these sessions, we will be showcasing demos to show you how the product works in real life in action. We've been talking about AI and AI workflows since 2023, but AI is no longer a pilot, right? Most enterprises are starting to deploy AI in production. In fact, Gartner says that by 2028, more than 95% of enterprises will be using LLMs, GenAI APIs, and models and deploying them into applications in production. So it's very important for enterprises to think about how do we govern various AI endpoints? How do we ensure security and access to these endpoints? And how do we observe what's really going on in terms of cost management, security, as well as double clicking into issues that might be coming up with these kinds of applications? But AI comes with its own set of challenges, right? It's similar to just like APIs. AI comes with its own set of challenges related to governance. How can I control the cost and ensure compliance with my organizational policies? How do I prepare my systems to proliferation of various AI agents, which would be in hundreds to thousands to millions as it scales? How do I ensure security and safety of my systems and applications? How do I monitor and troubleshoot my AI systems? And how do I empower my developers to build better AI systems faster? All of these are problems that we have dealt with traditionally with APIs, but AI, these problems are magnified to another other level. So let's figure out how API management can help you solve all of these challenges. Before we double click into API management, just wanted to provide context to everyone here. API management platform consists of two products, right? One is API management. It is our gateway solution to securely publish, manage, and analyze APIs across all environments through a managed gateway. We also have a self-hosted gateway offering, and together we call that as API management. We have API Center, which is our catalog to track, discover, and govern APIs within an organization, regardless of the type of APIs or the location where these APIs are located. Together, these two products form the Azure API Management platform, and that is what we'll be talking about throughout this presentation. So, Azure API Management has provided support across the customer lifecycle, all the way from design, develop, secure, publish, scale, monitor, and analyze for traditional APIs for over a decade. We have over 40,000 customers processing trillions of requests on a monthly basis. But we are evolving API management into a more of a universal gateway. We not only support traditional APIs, but we also support model APIs, including Azure AI Foundry, Bedrock, Google Vertex AI, OpenAI, Anthropic, Mistral, or any other place where your models are hosted. And similarly, we are also supporting tools, be it MCP endpoints, OpenAPI specs, or your own custom connectors that you're building. And finally, if you are building agents through specific protocols like A2A, Azure API Management also supports those things in applying the same governance lens that we apply to traditional APIs. So Azure API Management is considered more of a universal gateway. That is the direction we are evolving the product to, so that you don't need to piecemeal your efforts across various kinds of gateway solutions, various kinds of governance solutions, one solution to offer governance across all kinds of API endpoints. So it is your API gateway, it is your AI gateway, which includes a model gateway, tools gateway, or agents gateway. Everything all put together, a universal gateway for your entire product stack. So let's double click into what is AI Gateway, right? AI Gateway capabilities within Azure API Management, which we are simply calling as AI Gateway for simplicity, is the bridge to mediate all kinds of AI usage, right? On the left side of this slide, you see our clients. Clients could be users, clients could be apps and services, agents, or co-pilots. And on the right side, you see what these clients are trying to access. They are trying to access AI models from various sources that we just talked about. They are trying to access tools like MCP servers and APIs or agents. All of these things are mediated, the access from clients to these particular endpoints are mediated by AI Gateway, which includes governance, scalability, security, safety, observability, and velocity. Exactly the problems we talked about earlier in terms of how AI complicates governance, scalability, observability, velocity, and AI Gateway capabilities within API management is built to solve all those problems. Now let's double click into how are we solving those problems. Like I said, we are combining traditional API gateway capabilities and AI gateway capabilities to manage your entire API estate. So these are the columns you see are the various problems we had called out earlier. So we will be using a combination of capabilities that we already provide within our API gateway and a combination of capabilities that we have provided built specifically for AI purpose within the AI gateway capabilities. So for governance, we already API management has an extensive selection of policies. And similarly, we also provide federated API management with workspaces. We also have enterprise-wide catalogs. Now we are extending the same concept with approved models, MCP servers, skills, plugins, and A2A agents. You are able to apply granular token rate limits and quotas. Cost management is a big concern today in AI workflows and within enterprises. And using these kinds of specific capabilities, you are able to control and manage your costs. You also can enforce policies for MCPs and A2A endpoints to make sure that you have secured access to these endpoints and you are able to apply specific policies such as content safety, etc., to make sure you're not doing any harm or you're not leaking any secrets, for example. Similarly, within security and safety, we already support the OWASP API top 10 protections. We support client authentication and authorization, keyless management, identity, credential manager. All of these capabilities are extended to all the API management and as well as AI endpoints. So within AI Gateway, now we are able to moderate prompts and completions. We are able to prevent PII leakage, any kind of private information. We are able to prevent the leakage of that. Observability, API management provides robust observability with logs, metrics, and tracing. We are extending that with ability to track token consumption, log the prompts and completions, log MCP tool interactions, both the requests and responses, and tracing the entire end-to-end agentic interactions. Scalability, I won't spend much time here, but you can improve scalability. And let's take a look at what we do, especially for AI capabilities like saving tokens, improving latency and semantic caching, prioritizing routing to provisioned capacity and specific models, implementing model fallback in case of reliability issues or in case of cost concerns. SSE and streaming HTTP protocols. We support both protocols depending on whichever protocol your tool is built on. And finally, velocity. It's using API management. We are able to provide a developer portal. We have VS Code extensions, Copilot for policies, which will improve the velocity of your developers within your enterprise. We also have test consoles for tools directly built within our API management portal so that you can directly test the tools that you're building with MCP protocol. We're also extending that with AI Gateway with importing AI Foundry models tools from other providers. It's not just within Foundry or within API management, but you can import it from anywhere else. You can wrap existing MCP servers or external MCP servers hosted either on Azure or outside of Azure or even on-prem. You can wrap them within API management and make it a private endpoint to share with various kinds of clients. You can convert your existing estate of REST APIs to MCP servers so that you don't have to duplicate the work or invest more time that you have already invested in building all your REST APIs. You can discover and consume these assets from across the places and various agents via MCP server that we have created for API Center. So let's double click into model governance with API management. Let me invite my colleague, Mike Budzynski, to come over and discuss model governance. Mike, over to you.
Thank you, Anish. Anish did a great job explaining all the capabilities that we offer as part of Model Gateway in API management. They include token rate limits and quotas that allow you to monitor token consumption, attribute it to certain users or agents, and set up alerts or build dashboards based on that. You can also moderate prompts and completions, log them for your investigations or audit, as well as apply functions like semantic caching to reduce token consumption or the cost of actual token consumption on the models. You can also do some source of routing, for example, to prioritize per provision capacity for certain models and implement model fallback strategies. In terms of model backends, API management supports all sorts of model providers, including, of course, Microsoft Foundry, OpenAI, Google Vertex AI, AWS Bedrock, Hugging Face, and any other model provider. Clients include users, agents, and coding agents like GitHub Copilot. Let me show you a quick demonstration of how API management helps govern models. In this example, we'll be looking at the model deployed on AWS Bedrock. This model is deployed on AWS Bedrock in Amazon Cloud, and it is imported as an API in API management that has a few policies applied on it. One policy limits the number of tokens consumed by each user to 10 per minute, and the other policy specifies content safety. I have a sample application that loops requests to this model API to demonstrate the execution of policies. First, I will call this model to explain Azure API management in 10 words. The first request to this model succeeds with a proper answer in the response, but the second request fails because of the token limit policy. I have exceeded my allocated token quota, and now I'm being throttled by AI Gateway. Now I can also change the prompt to a hateful prompt, such as I hate you, and execute the model again. This time, AI Gateway will block this request due to the compliance of content safety policies that I applied. This is considered a hateful request, and AI Gateway successfully blocks it before it reaches the model in the backend. Of course, similar capabilities work today for OpenAI models, Microsoft Foundry models, and other models that are compatible with OpenAI. I'm also excited to announce that we are just GAing the capability for applying the same sort of policies to Anthropic and Vertex models. So starting June this month, you're able to apply those sorts of LLM policies like token limits, token metrics, content safety, semantic caching, etc., to models coming from the Anthropic provider or using the Anthropic Messages API and Vertex models deployed on the Google Cloud. You can also collect logs and metrics for those models, as well as import cloud operations as part of the Microsoft Foundry import in API management. I'm also excited to announce general availability of additional token metrics capability in API management. This allows you to collect metrics and build dashboards for all token types, not just completions and prompt tokens, but also thinking, reasoning, cache tokens, and other token types using the LLM emit metric token metric policy. This policy forwards the token metrics to application insights, where you can set up alerts or build more complete and accurate dashboards to represent token usage, or maybe even cost of consumption of models. I'm also excited to announce a new capability that's available now in preview called Unified Model API. This API creates a single API in API management for various backend model providers. For now, those backend providers are Anthropic models using the Messages API and OpenAI compatible models using Chat Completions API. You can have a client-facing Chat Completions API interface that automatically translates calls to Anthropic models and to OpenAI models. This allows users to standardize on a single SDK or a single client-facing interface, while you can implement a lot of different models on the backend. You can also use aliases a new functionality that's part of this feature to decouple backend and client model names. For example, you can create an alias called GPT that will forward the request to the GPT 5.3 backend. But with time, you can swap this alias, for example, to upgrade your model to GPT 5.4, maybe swap it for another model provider like Anthropic without affecting any clients. So clients will be able to just use that alias while you have full control over what's actually the backend model on the backend behind the API management. This unified model API also allows you to centralize governance of policies across models from different providers. So you apply your policy once and it works for all of these models on the backend. You can also configure failover across providers. So for example, you can failover from an OpenAI GPT model to an Anthropic Cloud model, even though they're technically different API formats on the backend, but API management handles the translation for you. Lastly, I'm also excited to announce general availability of Bring Your Own Model functionality in Microsoft Foundry. This capability allows you to add any model proxied by AI gateways such as Azure API Management or third-party gateways that is Chat Completions API compatible, and use that model for building prompt agents in the Foundry Agent service. You can learn more about this functionality at the link below. And with that, I would like to hand it over to Anish to talk about tool governance in API management.
Thank you, Mike. Excited for these new launches. Now let's look into tool governance within API management. Before we get started, let's talk about what exactly we define as tools. Tools are APIs or MCP servers that you use within your enterprise, basically to drive action. AI models and LLMs, they provide the intelligence, but in order to drive action, you need to have these agents and LLMs connect to these tools such as APIs and services to turn that intelligence into actions. But this creates a new set of challenges. Enterprises for the last couple of decades have built a huge sprawl and portfolio of APIs and various kinds of tools. How do they repurpose this into the new world of AI? API management could help solve for that particular problem, which we will dig into in a second. The more tools you add, the more risk you create. In fact, the risk grows exponentially according to lots of surveys, right? So where every tool you add, the potential security, compliance, and performance challenges increase exponentially. So how do we solve for these problems? Let's double click into that. AI Gateway, just like how it is the bridge to mediate model usage, it is also the bridge to mediate tool usage. We solve for the same issues such as governance, security, observability, velocity, and scalability when you are interacting with various kinds of tool backends, like I mentioned before. APIs, it could be cloud services or connectors. Here I have just listed a few examples such as logic apps, functions, container apps, etc. You could also want to mediate access to third-party MCP servers natively and apply the same set of governance policies that you're applying to your first-party APIs and services. You could talk to any kind of third-party MCP servers such as Atlassian, Stripe, Box, Neon, or anything else. So let's look at what can you do with Azure API Management today, right? One, you can create MCP servers. You can convert your existing portfolio of REST APIs into MCP servers in a matter of a few clicks. No rewrites. You can just expose any HTTP backend as an MCP server in less than a minute in a matter of a few clicks. You can also proxy existing MCP servers, either first-party MCP servers that you're hosting or third-party MCP servers hosted by another party, third party like we just talked about Stripe or Jira that you might be using in your organization, and proxy them with this particular gateway to apply the same governance and the same security perimeter. In terms of securing MCP servers, after you create, the next big challenge becomes how do I secure these endpoints to make sure agents and LLMs accessing these endpoints are authenticated, and we make sure that they have the right access and scopes to access these particular MCP servers. And similarly, we also make sure how do we streamline and simplify the access to these MCP servers, which might have their own auth mechanisms, such as API keys or OAuth. All of those things are supported using capabilities such as credential manager and policies within API management. The third part is, okay, you have created and you have secured these MCP servers. Now I want to apply various kinds of organizational policies, right? I might want to apply content safety policies where I don't want to leak any PII information. I want to apply throttling policies so that I will make sure the right kind of, there is no abuse of my tools by various kinds of agents and LLMs. So you can apply all kinds of policies, and all those are supported for all these MCP endpoints and tool endpoints. Lastly, observability for every call. Anytime you try to call a particular tool, you want clear logs, traces, and metrics to understand what exactly is happening so that you can root cause issues as well as improve the performance of your applications and the agentic workflows that you're building. So it's the same gateway, same policies, whether it's a REST client or an agent or an MCP-aware coding tool, we are able to support all of these capabilities within API management. So let's talk about what's new, right? We recently shipped more capabilities for MCP servers and tools within API management. So one of the first things we recently shipped was the ability to add MCPs to the product concept within API management. This enables you to bundle one or more MCP servers into API management products, subscriptions, quotas, and approval workflows. It gives you the ability to create specific bundles so that you can specify the specific set of curated rules for those particular products. You can also apply subscriptions and quotas and various kinds of approval workflows for those products. Similarly, we also got a lot of asks from customers, the ability to A/B test these kinds of MCP servers that are being created within API management. So we enabled MCP versions. So you can create multiple versions of an MCP server so that you can run various kinds of testing, experimentation, or even have one version in prod and one version in deployment and to start making changes simultaneously to test and to improve your development workflow. Then we also further improved the overall observability with more fine-grained data and metrics for MCP tools. It's more about having metrics, traces, and logs in open telemetry, and we are able to track end-to-end metrics for a request from the time it originates from a client to the time it hits API management gateway to the time it goes to a particular MCP server to understand which tool got invoked, what auth mechanism got invoked, etc. You have access to all of this information. And finally, we also improved our automation capabilities by making MCP a first-class element in Management API, our REST API for API management. So you can use this automation to directly create MCPs, secure MCPs, and apply policies directly through the REST API and not having to go through the Azure API Management portal. So let's look through a quick demo of the new capabilities we launched. It should be a very quick demo so that you understand where these capabilities are located and how you can leverage them. So this is my API management portal. And this is a basic V2 instance. As you can see in the TOC on the left side, I've clicked on MCP servers within AI Gateway. You can see a bunch of MCP servers already there. I'm trying to create an MCP server. I'm using an existing MCP server, a third-party MCP server, mcp.stripe.com. I've added a display name and a base path. And I'm also assigning it to a product. So you can see during the creation flow, anytime you can assign a particular MCP server to a particular product, and it gets assigned to that product. And then you can go to the product and start making all kinds of changes that you want to do. So that is the first feature we launched. The second thing, you can see that once the MCP server got created, you can apply various kinds of policies, and you also have settings there where you can apply subscription keys to authenticate access to this particular MCP server. Let's apply a policy. I will just apply a very simple access policy so that we understand that, hey, we can access this particular MCP server. Here, I'm just posting a particular key. It is just hard-coded here just for simplicity. We also launched a new test console with an API management. You don't need to go to an MCP inspector outside or spin up your own MCP inspector. The test console will automatically enable you to test the MCP server created. It is listing all the tools here, and you can invoke them directly from there. And lastly, like I mentioned, versioning, we also have the ability to version MCP servers that you create. So here I'm creating a V2 version of the MCP test build 2026 MCP server. As you can see here, I have two versions. There is the original and there is the V2 version with two particular private endpoints that I could use for experimentation, A/B testing, blue-green deployments, etc. So we have another demo. This would be quite interesting, I think. We also have enabled the ability to use API management for tool selection at agent design time. So Mike, my colleague, has created a good demo to showcase this capability. Let's walk through that now.
Let me show you a quick prototype of how AI Gateway simplifies agent tool discovery at design time. I'll start with a simple intent. I want to build an agent that calculates shipping costs for online orders. From that intent alone, GitHub Copilot queries AI Gateway's MCP server to discover available tools. It automatically selects the tools that matter, such as order lookup and US and international shipping cost calculation, and intelligently excludes tools that don't contribute to the goal. I review and confirm the selected tools, and Copilot generates the full agent code using the GitHub Copilot SDK. This isn't just a basic scaffold. It includes the correct tool definitions and chaining logic derived entirely from tool metadata and descriptions. At this point, the agent is ready to run locally or be deployed directly to Foundry. So how did we get here? First, a lightweight custom skill connects GitHub Copilot to AI Gateway, enabling Copilot to discover tools and generate the agent code automatically. Second, the GitHub Copilot CLI is configured with the AI Gateway's MCP server, which acts as the discovery endpoint for all tools exposed through AI Gateway. For this prototype, AI Gateway, which will combine the capabilities of API Management and API Center into a Foundry-native, multi-tenant, always-on component, is mocked with standalone API Management and API Center resources. API Center exposes the MCP server with all the tools automatically synchronized from API Management. Tools that don't match the developer's intent, like weather forecasting in this case, are filtered out by Copilot during discovery. API Management facilitates the tool's runtime and enables conversion of existing enterprise REST APIs, such as order lookup, shipping cost calculation, and weather forecasting, into MCP servers. Finally, we are also actively prototyping more advanced capabilities. This includes AI Gateway dynamically selecting tools at the agent's runtime, not just at design time, and ensuring that all model calls are routed through AI Gateway to enforce governance policies, such as token consumption limits.
Okay, that's all on tools governance. Let me invite my colleague Srikanth to walk through the enterprise catalog for AI assets. Srikanth, over to you.
Thank you, Anish. And we're going to talk about the enterprise catalog for AI assets. As enterprises scale their AI investments, one question keeps coming up. How do we manage all of it? The agents, the skills, the MCP servers, and models. How do teams discover what exists and ensure quality and prevent duplication? That's exactly what Azure API Center solves. It's the enterprise catalog for all your AI assets, a single system of record for the enterprise where every tool an agent might call is registered, tracked, and discoverable across your organization. The catalog spans across 4 asset types: REST APIs, MCP tools, skills, plugins, models, and agents. Keeping the catalog current is effortless. You can register via portal, the CLI, or sync directly with your GitHub repo. There is no manual drift, and assets ship as and when new commits are made. Quality assessment also is provided for all these assets, using LLM as a judge to evaluate your skills for clarity, parameter design, and safety, so developers and agents can trust what they consume. And for the agentic world, API Center serves as the marketplace for agents, exposing a marketplace endpoint that enables developer tools like Claude Code and Copilot CLI to discover and load enterprise skills, plugins, and MCP servers directly from the catalog. With the same lifecycle and quality signals your platform teams curate. All of this works across Azure, other clouds, on-premises, and third-party SaaS. One catalog, every asset. Let's see a demo of it in action.
API Center is the enterprise catalog for all your AI assets, including skills, plugins, MCP tools, and agents. Let us start with registering skills. Click on Register a Skill in the Assets sidebar menu. Provide details of the skill's capabilities, use cases, and behavior. You can also enter the Git repository URL for the skill source code. In this example, we added a new code review skill to the API Center asset catalog and provided the Git repo URL of the skill markdown file. With skills registered, let's look at how to keep them up to date at scale. To automate skill registration and updates, integrate a Git repository with your API Center. Any skills added or updated in the repository are automatically synchronized with your API Center inventory, eliminating manual updates and keeping your catalog always current. In this demo, we have integrated the Azure Skills Git repository to show how seamlessly external skill sources can be connected and kept in sync with API Center. Once the Git repo is synchronized, Azure API Center will automatically import all Azure skills as assets, making them easily discoverable across the enterprise. API Center Portal provides an easy way for developers to discover skills and its capabilities. Let us try to find the Azure Cloud Migrate skill from the Azure Skills catalog, which we just imported through the Git repository integration. Azure Cloud Migrate skill is essential for agents looking to assess and migrate cross-cloud workloads to Azure. Clicking on the skill name in Azure API Center Portal opens the skill's definition, including its reference documentation, common tasks, and its defined inputs and outputs. Further, developers can contribute new skills by committing directly to the Git repository integrated with API Center. And once pushed, those skills are automatically synchronized with the catalog and made available to the entire team without any manual intervention. Let us now talk about skills assessment. AI skill assessments using the LLM as a judge technique leverage a large language model to evaluate AI outputs against defined quality criteria, scoring responses across dimensions like accuracy, coherence, and helpfulness. The judge model can be prompted with rubrics, reference answers, or pairwise comparisons, enabling scalable feedback at a fraction of the cost of human annotation. API Center comes with default skill assessment criteria out of the box, evaluating skills across 4 key dimensions, each scored on a 1 to 5 scale with a default threshold of 3. Documentation clarity evaluates how clearly a skill's purpose and behavior are communicated. Help completeness assesses whether the output serves as a comprehensive standalone reference. Discoverability measures how easily functionality can be navigated and found. Safe usage evaluates whether sufficient guidance is provided for safe operation. Enterprise platform administrators can further extend these defaults by defining custom assessment criteria tailored to their organization's specific standards, compliance requirements, and governance policies. Once skills assessment is enabled, developers can view a detailed AI quality score report for each skill directly within the API Center portal. This report provides an at-a-glance pass or fail status along with per-dimension scores and actionable feedback. Alongside the LLM-based scores, the report includes structural checks, verifying foundational elements like valid front matter, skill name, and body content, and schema validation, which flags missing sections such as examples or error handling. As a developer, this means you can quickly understand the quality and reliability of a skill before adopting it, making informed decisions about which skills are ready to use and which may need further refinement. Let us now transition into MCP tools. As the MCP ecosystem grows, organizations need a scalable, automated way to register and manage MCP tools without manual overhead. To automate MCP tool registration and keep your inventory up to date, you can integrate a Git repository with your API Center, eliminating manual onboarding and ensuring your catalog stays in sync as tools evolve. Any changes pushed to the repository are automatically reflected in the catalog, giving teams a single source of truth for all MCP tools across the organization. In this demo, we showcase this end-to-end by importing the Azure MCP server into API Center through Git repo sync, demonstrating how quickly a real-world MCP server can go from a repository to a fully registered, discoverable asset in your catalog. The API Center portal enables developers to discover MCP servers and interact with MCP tools by listing and running them directly. Through the built-in MCP inspector, developers can explore available tools, inspect their inputs and outputs, and test them in real time, all without writing a single line of code. In this example, the API Center data plane MCP server lets developers list every MCP tool in the catalog and search for a specific server, making it easy to evaluate and integrate the right tool into their workflow. Now let us talk about plugins. Plugins are self-contained extensions that supercharge any supported AI development tool, adding custom commands, agents, hooks, and MCP integrations to 𝗬𝗲𝗍𝗍𝗫, Claude Code, and beyond. Here we are on the plugin registration form in Azure API Center. We start by providing a title, summary, and description to make the plugin discoverable and meaningful to developers and agents browsing the catalog. We then specify a version to track releases over time. What makes this powerful is the ability to bundle skills and MCP servers directly within the plugin, so consumers get a single, self-contained asset that is not just discoverable, but immediately actionable. With just a few fields, the plugin is registered, governed, and ready to be consumed by agents, copilots, and developers across your organization. The API Center portal gives developers and agents a single place to browse, search, and discover plugins alongside APIs, skills, and MCP servers, eliminating scattered repositories and tribal knowledge. Each plugin surfaces its bundled skills and MCP servers in one unified view, giving consumers everything they need to evaluate and connect with the right asset quickly. Now let's look at how the API Center data plane brings it all together. API Center exposes a marketplace endpoint through its data plane API, surfacing plugins directly to Claude Code and 𝗬𝗲𝗍𝗍𝗫, making discovery seamless without leaving your development environment. Register the endpoint with 𝗬𝗲𝗍𝗍𝗫 in one step, and the full plugin catalog is instantly unlocked. From there, browsing, selecting, and plugging in happens right from the CLI, keeping workflows fast and friction-free.
Let's now transition into agent governance. As agents proliferate, raw unmediated access to backends doesn't scale. Users, apps, agents, and copilots are all making calls, and A2A REST and HTTP backends spanning any cloud and on-premises. You need something in the middle that you can trust, and that's the AI gateway. It delivers 5 things: governance, scalability, safety, and security, observability, and velocity. One bridge for every agent fully governed. And now for an announcement. Agent-to-agent support in Azure API Management is generally available today. A2A is becoming the backbone of multi-agent architectures. And starting now, you can bring your A2A agents under the same enterprise-grade management you rely on for REST APIs. Same governance, same security, and same observability. Today, we are GAing governance, security, and observability across A2A agents APIs alongside all your other APIs. You can expose agent cards and runtime operations. You can log open telemetry traces using Gen AI semantic conventions for deep and standardized visibility. You can apply policies like throttling, IP filtering, and content safety to every agent call. And you can inventory and publish APIs. As you can see, registering an A2A agent is now very simple, with agent-specific metadata like agent card and agent URL surfaced natively alongside lifecycle and deployment details. A2A support is now generally available. And that's a wrap. Thank you for attending the Azure API Management session at Microsoft Build today. What we showed you today is all available for you to use and for you to build. More details on it can be found at AKMS APIM blog. We can't wait to see what you will build with Azure API Management. Thank you.